Hello and welcome to your physics class, and today we're going to be talking about falling objects or free fall. Now, so far in this chapter of motion in one dimension, we've noticed that the velocity and the acceleration that we've talked about has been horizontal, in other words, in the x-axis. Today we're going to talk about falling objects. Now notice that there's a difference between falling objects and projectile, because a projectile is when a force acts on an object causing it to move in the y-axis, whereas a falling object is when something literally falls down. So the first thing we're going to do is we're going to define what free fall is. We're going to see some of the formulas, and then we're going to go over the example. Now, we talk about free fall acceleration or free fall objects when an object is dropped. Think about, when you take a ball, a paper ball, and you have a paper that is not folded, and you throw them down or let them fall on the floor. That's an example of free fall. Free fall acceleration, and the reason I give that example is you'll probably understand that a little better after we develop what free fall is. And we can define free fall as the motion of a body when only the force of gravity acts on the body. Now we do know for certain that if I take a crumbled up piece of paper and if I take a unfolded piece of paper, if I let them fall at the same time, and I'm actually going to go ahead and do that real quick, to kind of explain what I'm trying to say. So that's why I'm kind of stepping out of camera for a second, and I'm actually going to go ahead and do that. So free fall is defined again as the motion of a body when the force of gravity is acting on the body. So we have a piece of paper that is unfolded and a piece of paper that is balled up. Now, if we look at that definition and we say when the force of gravity is the only thing acting on it, then that means that both objects should fall on the floor at the same time. And they don't, because it takes the paper that's not folded longer. What that means is that this definition is true, but we are assuming that the only force acting on it is gravity, when in reality there are other forces that act on a falling object. But in order for physicists to understand the nature or to understand this phenomenon, they assume that gravity is the only thing acting on it, and that object is in what we call a vacuum, which is in the absence of air resistance. So based on that and other investigations, one of the formulas that we use for talking about free fall object is actually the change in y equals the initial velocity multiplied by the change in time plus 1/2 of the acceleration multiplied by the change in time squared. And to find final velocity of falling objects, we say that the final velocity equals the initial velocity plus the acceleration multiplied by the change in time. So what we're actually going to do is we're going to talk about this in the example. Now this example is actually found on page 61 of your textbook, so you can go ahead and look at it. And the work that we're going to have after this example is actually on page 62. So I'm going to go ahead and read the problem. It says, the famous gateway to the West Arch, located in St. Louis, Missouri, is almost 192 meters tall at its highest point. Suppose Sally, a stunt woman, jumps off the top of the arch If it takes Sally 6.4 seconds to reach the base to reach the safety pad, at the base of the arch, what is her average acceleration and what is her final velocity? So we have some information, and again, right, when you read the problem, you say Sally jumps, one has to read the problem, the sentence next to it, so that you know that Sally is a stunt woman and she's just not someone who is an adrenaline junkie. Well, maybe she is if she's a stunt woman. But if you read the problem, we do have some information. The first information is that the change in y is 192 meters, but we say it's negative 192 meters because remember when we started talking about motion in one dimension, north is positive, south is negative. So if she jumps and she starts falling downward, her displacement is actually to the south, which means it's negative. So 192 meters, negative 192. The initial velocity is 0 because we're assuming that she's standing there and then all of a sudden she just jumps. So we're assuming that her initial velocity is 0. The time it takes her to reach the top of the archway all the way down to the base of the archway is 6.4 seconds. And we're asked to find the acceleration and the final velocity. So I'm actually going to go ahead and move the camera a little bit to the other side so you can see what I'm going to do now. I actually have the formulas right there, and I'm going to go ahead and zoom in a little bit. And the formula says that the change in y equals the initial velocity multiplied by the change in time plus 1/2 multiplied by the change in time squared. So let's just plug in the numbers here. And our change in y is actually negative 192. I'm using this formula. The change in time, or the initial velocity, excuse me, is 0. The change in time is 6.4 seconds because that's how much it takes her to reach the bottom, plus 1/2 of the acceleration, which is what we don't know, multiplied by the change in time squared, which is 6.4. So 0 times any number is 0, so we say negative 192 equals 0 plus. Now you have to multiply 6.4 squared, and 6.4 squared is 40.96, so that'll be plus 1/2 of the acceleration times 40.96. And what we're going to do now is we're going to multiply 40.96 times 1/2, or divide it by 2, which then would leave us with negative 192 equals 0 plus, and half of 40.96 is 20.98, so 20.98. Of course, 0 plus 20.98 is 20.98, A, of course, the acceleration. So we have negative 192 equals 20.98 A. So we're going to divide by 20.98. 20.98. This is going to cancel out. And our acceleration is going to be approximately negative 9.4 meters per second squared. Now it's negative because we remember that the object is falling, or that the stunt woman is falling in this case. So that means that the acceleration is negative because she is eventually going to fall on the safety pad and it's going to stop moving. And of course, because she's moving downward, she's falling. So I'm going to go ahead and erase this, and we're going to look for the final velocity. Now that I have my acceleration, which again is approximately 9.4 meters squared, let me write it here, negative 9.4 meters per second squared, and this is approximately. So now we're going to plug that in, and we're going to say that the final velocity equals the initial velocity, which once again is 0, plus the acceleration, which is negative 9.4, multiplied by the change in time, which is 6.4. And when we multiply that, we say that our final velocity is 0 plus negative 9.4 times 6.4 is approximately negative 60.6 or 0.16. And 0 plus negative 60.16 is the final velocity of negative 60.16 meters per second. In your textbook, they use the significant figures and they kind of round it down. So they will say that the final velocity equals negative 60 meters per second, and which is actually negative 6 times 10 to the power of 1. Okay? So whether you get negative 60.16, whether you round that down to negative 60 meters per second, or whether you write it as negative 6 times 10 to the power of 1 meters per second, it all means the same. So that's how you work or find the displacement and the final velocity of falling objects. Once you've seen this video, you're going to go to page 62 and answer problems 1 and 2. Page 62, problems 1 and 2. This is the end of this video lesson, and I will see you soon. So